In this video, we will be discussing solving systems of linear inequalities. Go ahead and get your notes ready, and don't forget to rank this vocabulary word. Pause the video if you need to finish getting your notes ready. When a problem uses the phrases like greater than or no more than, you can model the situation using a system of linear inequalities. A system of linear inequalities is a set of two or more linear inequalities with the same variables. And the solution to a system of inequalities is often an infinite set of points that can be represented graphically by shading. Remember that we choose to shade above or below based on which way the inequality symbol is facing, and that if we have a less than or a less than or equal to, we shade below. And that if we have a greater than or equal to symbol, we shade above. And that these rules apply when y is isolated. So we're going to be isolating y during the whole lesson. So these rules apply when y is isolated. In other words, when the equation is in slope-intercept form. Also remember that the line is dotted when you don't have the equal to underneath the less than or equal to, and that it's solid when the line is underneath there. So just a little bit of review from things that we covered in chapter 2. Okay, so when you graph multiple inequalities on the same graph, the region where the shades overlap is the solution region. So we're looking for the overlap. Okay, so here's our first example. Both of these inequalities already have y isolated, so we don't have to worry about getting y by itself. We just need to graph the inequality and then do the shading. So for this one, we want a dotted line. So the y-intercept is -3. So plot your y-intercept, and then the slope is 1/2. So you're going to go up 1 over 2. And then we want a dotted line. So graph your dotted line. And then I'll change colors here. Let's go with yellow. And we want to shade below. Hopefully you can see that. Okay, now the other one we'll make green. Okay, so its y-intercept is 2. And its slope is up 1, backwards 1. And we want a solid line for this one. Okay, and we're going to shade above. For this one. Okay, so hopefully you can see that there are some green and yellow areas shaded. Okay, so let's go with blue for the solution region. So the solution region is the place that got colored with both yellow and green. So you're probably going to want to do your homework with colored pencils. And the solution region was the area that got colored with both yellow and green. So it's the overlapping region. So it would be that area right there. Because you see you have some green, you have some yellow, but the blue is the both region. Okay, next example. Alright, so y is by itself on both of these also. So let me pick a different color than yellow because that one didn't show up very good. Let me pick, we'll pick purple. Alright, so y is less than -3x plus 2. So the y-intercept is 2. And we could go up 3. Let's go down 3. 1, 2, 3, forward 1, since it's -3. And we want a dotted line. Okay, so, and we want to shade below because it's less than. Okay, and then we'll go green. Greater than or equal to -1. Okay, so here's -1. And this one's going to be a solid line. Remember, Y lines are horizontal lines. Okay, greater than or equal to. So that's going to be this. So where do we end up with purple and green? Right over there. So let's get a blue to show that. So the purple and green area is our solution region. So that's going to be right there. Okay. Next example. Okay, this one we need to get Y by itself first. So let me get some black to do that. Okay, so right here we need to subtract X. So we have -3Y is less than -X plus 6. Divide by -3. So Y, remember when we divide by a negative, we need to flip the inequality. And remember that's a -1 in front of that, so that makes 1/3 X minus 2. Now we have Y by itself. We also need to get Y by itself on this one. That's -2X. Okay, 1.5 is 3/2. So now we have Y is greater than -2X plus 3/2. Now we can graph them. Okay, so I liked the purple, so let's go get purple for this first one. Okay, -2 up 1 over 3. Okay, dotted, they're both dotted lines. And we're going to shade above for the purple one. Okay, and then I think we were using green. Okay, so positive 1.5. Okay, and then up 1, 2, backwards 1, dotted line. Also shade above. So this one goes here. Okay, and you can see where it's both purple and green. Color, where's my blue? Okay, so the blue is going to be right to there and stop. Okay, so your overlapping region is right there. And there's your answer. Okay, let's look at a couple of application problems here. Oh, no, one more example, sorry. Okay, when you get Y by itself right here, subtract 2X. So we would have Y is less than -2X plus 1. Okay, and this Y is by itself. Okay, purple. Y is less than or equal to 4. Okay, so solid line. Shade below. So it goes all the way down there. Okay, green. Here. +1 for my y-intercept. Up to backwards 1. Dotted line. Dotted line. And less than. So below, okay, blue, and up to this line here, and then shade below. So pretty significant answer here for my double shaded region. And there you go. Okay, now I think it's time for an application. There we go. Okay, Lauren wants to paint no more than 70 plates for art. Okay, keywords here. No more than means less than or equal to. It cost her at least means greater than or equal to $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. So we're making two different kinds of plates, and she wants no more than 70 plates. Okay, so red plates and gold plates. So red plates, gold plates, and we don't want to make any more than 70 of them. There's one inequality. Okay, she wants to spend no more than $215. There's another inequality. Write and graph a system of inequalities that can be used to determine the number of each plate. Okay, anytime you're dealing with word problem inequalities, you're always going to have this inequality. X is greater than or equal to 0, y is greater than or equal to 0. What that means basically, we're in the first quadrant. Okay? Here's another one. We're making no more than 70 plates. Your other one has all your money in it. No more than $215. Okay? So let X represent the number of red plates, Y represent the number of gold plates. The total number of plates was X plus Y is less than or equal to 70. I just on the other slide was basically telling you you had red plates and gold plates, and they added to 70. Okay? The amount of money you're willing to spend, remember I said all your money goes in your other inequality? There it is. Here's all the money. It was in the other inequality. Okay, so your system of inequalities is this. Remember I also said you're always going to have your X greater than or equal to 0 and your Y greater than or equal to 0. That basically means that you're in the first quadrant. Okay, so here's the system. Here's your plates. Here's your money. That $50 thing that was in the equation basically was that it cost you at least $50 plus $2 per red plates plus $3 for gold plates. And you can't spend any more than $215. That was all the rest of the money is all in one inequality. Now you're graphing all of them. Okay? Here's the first one. This was a less than or equal to, remember? Okay, so you get Y by itself and you shade below it. So this was Y is less than or equal to negative X plus 70. It had a negative 1 slope. Your y-intercept was 70. This one here, if you get y by itself, you subtract 50 first. So you would have 2x plus 3y equals 215 minus 50. So you have 5, and then you have 11 minus 5 is 6, is 165. Then you would have 3y, we have a less than here, is less than or equal to negative 2x plus 165, and then you divide by 3. So you have y as less than or equal to negative 2/3 x plus, and then you take 165 divided by 3. That's 5, 15, and 5. It's 55. So your y-intercept is 55, and then your slope is negative 2/3. That's why the blue line is where it is. Okay, and then you check your test points to see. And then your overlapping region is your solution region.